Are you ready for the late lunar show? Maybe you want to take an early nap. Welcome back to Techstination. I'm Fred Fishkin. Joining us is Andrea Jones, Public Engagement Lead for NASA's Lunar Reconnaissance Orbiter mission. Hi, Andrea.
Hello, thanks for having me today.
Great to see you. With the focus you have on lunar science and exploration, this, I assume, is a pretty exciting night ahead. Tell me what's going to be taking place.
Sure. So tonight we have a lunar eclipse, a total lunar eclipse. So that's when the sun, the earth, and the moon all line up in space. The moon will move into the shadow of the earth. And so the earth will block most of the light from the sun. We'll see this beautiful red moon. And before we see that, we'll actually see the moon sort of disappearing into Earth's shadow. It'll look like a big cookie in space with bites getting taken out of it, bigger and bigger bites. And then we'll see the total lunar eclipse, the red moon, and then that process will happen in reverse with some as the moon emerges from Earth's shadow.
Why will it appear red?
So that's a beautiful reason. So the moon turns red during a lunar eclipse because the light from the sun that's getting to the moon is filtered through Earth's atmosphere. So just like you see a red sky at sunrise or sunset, that's what's happening. And so all those sunrises and sunsets on Earth at that moment are being projected onto the moon. And so the moon turns red. If you were standing on the moon looking back at the Earth, you'd actually see a red ring around our planet.
So, when and where do we look, and what tips might you have? And this is the whole country?
So this is the whole country, the whole Western Hemisphere is going to be able to see this tonight. So if you're on the East Coast like I am, so you'll see a partial lunar eclipse starting around 1 a.m. So get that nap, like you said, and get out there. The total lunar eclipse will start a little before 2:30 in the morning, and then it'll last for about an hour until about 3:30 in the morning. You'll see the rusty red color. It'll actually change a little bit to orangey, brownish hues. You might see the stars pop out. You might see some planets in the western horizon. And then we'll see partial phases starting from 3:30 till about 4:30 in the morning.
And unlike a solar eclipse, you don't need to do anything special. You can just look at this, right?
There are no safety concerns for a lunar eclipse. If you can see the moon, you'll be able to see the eclipse. You can look at it with your naked eye, no problem. If you have a telescope or a pair of binoculars, that can let you look at some lunar features. If you're able to get away from the bright lights of cities or street lights, that'll give you a better view, but no special equipment is needed. Just get out there and look up.
And hope the clouds stay away, right?
And hope the clouds stay away. Yes.
Now, this takes place on Pi Day, the 14th. So, what's the significance here?
Yeah, so pi is a really important number for both math and for science. And so it's just, it happens to start with 3.14. So on the third month of the year, on the 14th day of the year, we celebrate Pi Day. And the lunar eclipse actually has calculations that are important for pi, or pi is important for making these calculations, I guess. So we know the time that the Earth's shadow will fall onto the moon because of calculations using pi. So this is an opportunity for a really beautiful and delicious celebration of science. You can have some pie while you're looking at the lunar eclipse.
Maybe a tomato pie, right?
Or yeah, that would be great.
Tell us about the work you're doing with the Lunar Reconnaissance Orbiter, and that's going on right now.
Absolutely. So the Lunar Reconnaissance Orbiter has been at the moon since 2009, and this is an amazing mission that is helping us really reshape our understanding of our nearest neighbor in space. So we're watching the moon changing before our eyes. We're seeing new impact craters form. We're monitoring water moving on the surface of the moon. So not much, just little bits, but we can see them move throughout the lunar day. We're also seeing the solar wind interacting with the lunar surface, and we're getting ready to go back. So if we want to go back to the moon with people, as we're going to do with our Artemis program, we want to know where to land safely, what resources are available, and what might be really interesting for our scientists to study with the help of astronauts. And the Lunar Reconnaissance Orbiter is getting us ready.
Some of us might be scratching our heads. Water on the moon? Does it ever
Yeah.
rain there? How does this happen?
Yeah, so we have water on the moon, potentially from interactions with the solar wind that can actually produce water on the moon. There's also delivery from comets. One of the places we're really interested to study is the south pole of the moon. That's where we're going with our Artemis 3 astronauts. And there's deposits of water ice in permanently shadowed craters on the moon. The moon's only tilted a little bit on its axis, so some places on the moon's poles don't get any sunlight directly. And so they're really, really cold and might trap ice that we could either use for exploration or to learn more about what's happened on the moon over time.
So this is all helping to pave the way for astronauts to live and work on the moon.
Absolutely, yes.
Exciting. For more info, where can we go and any tips you have on staying awake tonight?
So sure, if you'd like to learn more about the moon and about the eclipse, you can go to science.nasa.gov/moon. And if you want to stay awake, I like a big cup of hot chocolate. I think that works for me.
Better than coffee, huh?
Well, I do want to go back to sleep afterwards, but I'll see what you think for yourself.
Terrific. Andrea Jones, congratulations on the work you and the team are doing, and thanks for spending time with us.
Thank you.